It weighed 800 tons. It stood 100 feet over Lake Erie, and in one bite it could swallow 17 tons of raw iron ore gone in about a minute, dropped into a waiting rail car 100 feet below the place where it started. For 80 years, 4 of these things stood on a strip of land called Whiskey Island, just west of downtown Cleveland, doing the one job they were built for: tearing the guts out of freighters faster than any machine before or since had managed. The men who worked them had a name for the job. They called it feeding the hog. The machine itself didn't need a nickname dressed up any softer. It already had one, and it stuck for a century. The Hulett. Picture the cab. A steel box about the size of a phone booth, bolted into a vertical leg of moving iron, suspended 100 feet above black water and broken rock. Inside it, one man. Above him, nothing but open sky and a cantilevered arm groaning under its own enormous weight. Below him, directly below him, with nothing between his boots and open air but a thin steel floor, a bucket built to grab 17 tons of ore in a single closing bite. Close enough that if the chains ever let go, he wasn't going to get a warning. He was going to get a sound, and then nothing. That was the job. 8 hours a day, sometimes more, riding a machine that hung its single most violent motion directly over the one man controlling it. And he wasn't the only one in danger. When a hold ran low and the bucket couldn't reach the last scattered pockets of ore, somebody had to climb down into that hold on foot, with a shovel, and work in the exact space the bucket still swung through on every pass. They called those men ore hogs. Some say it was said with respect, some say it wasn't. Either way, here's the part that should bother you. Before we go any further, nobody kept a clean count of what that job cost the men who did it. Hold on to that. We're going to come back to it, and it's not going to feel better the second time. Here's what should bother you even more. The single most important part of this machine wasn't the engine, it wasn't the gears, and it wasn't the boiler. It was a 6,000-pound counterweight, a deliberately unbalanced hunk of dead iron, bolted to the opposite end of the arm, that let gravity itself do the deadliest, the heaviest part of the work instead of the motor. We're not explaining that yet. Just remember, it's there. It's the secret that made this machine a marvel of engineering and, as it turns out, the same secret that decided, decades later, that nothing could be done to save it. Because in June of 2024, after surviving the ice, the dust, 80 years of grinding ore yard labor, and 3 decades of lawsuits fighting to keep it standing on Whiskey Island, the last Hulett left in Cleveland was cut into pieces and sold for scrap, not by accident, not by storm or structural failure, on purpose, with a torch, while people who had spent their entire adult lives trying to stop it stood and watched it happen. This is the story of the machine that built a steel empire on the shore of Lake Erie, and the machine that nobody, not the courts, not the engineers, not the men who loved it most, could ultimately save. Carnegie's gamble. Before the Hulett, there was just men, shovels, and time. A lot of time. In the 1850s, and for decades after, unloading a Great Lakes ore boat meant exactly what it sounds like: a crew of men climbing down into the hold with shovels and wheelbarrows, filling buckets by hand, hauling them up on chains, dumping them, and starting the whole grinding cycle over again. A ship carrying 300 tons of iron ore could take the better part of a week to empty completely. 100 men working 12-hour shifts could move maybe 5,000 tons between them. The cost ran close to 19 cents a ton, and every cent of that price was paid in human backs and human hours. So how bad did it actually get before something changed? Bad enough that it was holding back an entire industry. Rich iron ore had been discovered in Michigan's Upper Peninsula back in the 1840s, and by the time the late 19th century rolled around, the mines up there were producing faster than the docks could move the ore south to the steel furnaces screaming for it. That bottleneck wasn't a person. It wasn't a villain you could name and blame. It was slow, expensive, and getting worse every single shipping season, and nobody had a real answer for it. Think about what that week of unloading actually meant on the ground. A freighter sat tied up at the dock, fully loaded, earning its owners nothing while it waited. Men climbed down narrow ladders into a hold already half filled with ore dust thick enough to choke on, swinging shovels in a space barely tall enough to stand upright in. Hour after hour, in summer heat that turned the inside of a steel hull into an oven. Wheelbarrows rattled across uneven planks, slick with ore dust and lake spray. A man slipped, or a load shifted wrong above him on a hoist chain, and there was no machine watching his back, just the next man in line, hoping it wasn't him next. Multiply that by 100 men, by a full week, by every single ship waiting its turn on the lake. That was the cost of doing business before George Hulett ever drew a single line on paper, paid first in backs and hands, only second in cents per ton. Enter George Hulett, Connonote, Ohio. Born in 1846, the kind of small-town tinkerer nobody, pictures changing an entire industry from the ground up. He ran a general store for 15 years in a town most people couldn't find on a map. He sold produce in Cleveland for another decade after that. By the time most men his age were thinking about easing into retirement, George Hulett was thinking obsessively about gravity and about a problem nobody had managed to solve. His idea sounds almost too simple once you say it out loud. A cantilevered arm, hanging off a traveling gantry, with a clamshell bucket on the end that could reach directly down into a ship's hold and grab the ore itself. No wheelbarrows, no human chain passing buckets hand to hand. Just steel, doing in seconds what used to take 100 men an entire day. But an idea is cheap. Building it was not. Who would actually risk the money on an unproven contraption from a former produce salesman? Hulett convinced the firm of Webster, Camp and Lane in Akron to build the very first machine entirely on speculation, $45,000 of their own capital, with no guaranteed buyer waiting on the other end. If it failed on the dock, in front of witnesses, they ate every dollar of that loss themselves. And then the bet got bigger, and far more public. Word of the project reached Andrew Carnegie, the single most powerful man in American steel at the time, and Carnegie did something that should make your palms sweat just picturing it. He didn't send an engineer to file a report. He showed up in person, brought along Charles Schwab, his own company president, and stood on a Conneaut dock in 1899 to watch this thing work or fail in front of him in real time. His terms were simple and merciless. If it worked, he'd buy it. If it didn't, so what did Andrew Carnegie actually see that day? A machine that looked, by every surviving account, like an enormous grasshopper. A long, jointed arm, lowering itself down into a ship's hold, balanced on the far side by that 6,000-pound counterweight, letting the whole assembly drop under its own dead weight instead of fighting gravity with raw horsepower the entire way down. The clamshell jaws snapped shut around 10 tons of iron ore in one motion. The arm rose. It swung over toward the dock. It opened. 10 tons, gone, dumped into a waiting rail car, the entire cycle taking about 60 seconds from bite to drop. It worked. Flawlessly, by every account that survives from that morning, Carnegie bought in on the spot. And word of the Conneaut demonstration spread through the steel industry almost immediately. Within a handful of years, every major ore handling operation on Lake Erie was asking the same question. How fast can we get one of these on our own dock? But here's what nobody standing on that dock was thinking about as they cheered the demonstration. They'd just watched a single machine prove it could move more ore in 1 minute than 10 exhausted men could move in an entire hour. Nobody in that crowd was asking what happens when that same arm, swinging that same bucket, has a man standing directly underneath it on some ordinary Tuesday a decade from now when there's no audience watching, no engineer holding a stopwatch, and nothing is supposed to go wrong at all. That question was still years away from mattering. For now, the raw numbers did all the talking that needed doing. Where 100 exhausted men once moved 5,000 tons of ore in 12 back-breaking hours, 4 Huletts working together could move 10,000 tons in under 5 hours, with a crew of just 25 men handling the whole operation. The math wasn't subtle, and it wasn't close. The old way of unloading a Great Lakes freighter was dying in front of everyone's eyes, and absolutely nobody in the iron and steel business needed convincing twice. They'd built the beast. They'd proven, once, in perfect conditions with the entire industry watching, that it could do exactly what George Hulett promised it would do. Now came the considerably harder test. Could it pull off this same trick 10,000 more times, completely unsupervised, for the next 80 straight years without quietly killing the men whose job it became to run it? The grasshopper's iron guts. The Conanut machine was a proof of concept, nothing more. What came right after it was an arms race up and down the entire southern shore of Lake Erie. By 1912, the Pennsylvania Railroad wanted Huletts of its own, and the company building them by then, known as Wellman Seaver Morgan, right there in Cleveland, wasn't building demonstration toys anymore. The new generation, installed on the Cleveland and Pittsburgh ore dock on Whiskey Island, weighed roughly 800 tons apiece. They stood a full 100 feet tall. Their buckets had grown from the original 10 tons to 17. And critically, they'd been converted from steam power over to electricity, which meant trading one entire category of danger for another. No longer just a pressurized boiler waiting to fail. Now, it was heavy electrical current running through 800 tons of exposed structural steel, standing in lake effect, wind, ice, and salt spray, 12 months out of every year, including the brutal stretch of a Cleveland winter. So how did the thing actually move, mechanically, from one end of the dock to the other? Picture 2 parallel sets of railroad tracks running the length of the dock, with 4 more tracks laid in between for the ore cars themselves. Steel towers, each one riding on its own wheeled trucks, supported a long horizontal girder spanning the whole arrangement. Along that girder ran a carriage that could slide toward the water's edge or back toward the rail yard as needed. Hanging from the carriage, the walking beam itself, the arm, which could be raised or lowered on command. At its far end, a vertical leg. At the bottom of that leg, the bucket. And here is where the genius of the design and the danger of it become the exact same fact, just described twice, from 2 different angles. That 6,000-pound counterweight we mentioned a moment ago, it sat opposite the bucket on the beam, deliberately unbalanced on purpose, so the arm wanted to fall the instant you released the brake. Gravity did the heaviest lifting in the entire operation, literally, which meant the motor never had to fight physics every single time the bucket needed to drop into a hold. That's brilliant, efficient engineering. It also means you've now built an arm that, once it starts falling, is not politely waiting around for a motor to gently slow it down for you. It's an unbalanced mass of raw steel obeying gravity on its own schedule, and gravity does not negotiate with anybody standing in its path. The bucket itself, a clamshell jaw built to bite down on 17 tons of ore in one single closing motion. Now picture that bite happening anywhere within reach of a human body. And remember, it routinely did, because men were working in that exact hold while the bucket kept swinging. But what powered all of that closing force in the first place? In the original Conneaut machine, it was steam, a boiler under pressure, feeding a system that had to be tended, watched, and trusted not to fail at the worst possible moment. By the time the Whiskey Island giants went up in 1912, and especially after John Alberg's electrical conversions through the 1920s, the power had shifted to heavy current motors threaded through the towers and the carriage. That solved one old problem and handed engineers a brand new one. A boiler announces its distress. It hisses, it groans. It gives a man time to react before it fails outright. Exposed high-voltage wiring, soaked in lake spray and crusted in ice through a Cleveland January, does not always give that same warning. It just works, silently, until the one day it doesn't. So where did the operator actually sit through all of this? Not safely back on solid dock, watching the whole thing unfold from a comfortable distance. He sat in a cage built directly into the vertical leg, positioned right above the bucket on purpose, because that exact spot gave him the single clearest view straight down into the ship's hold. Best visibility anywhere on the machine. Also, by simple consequence, the single worst seat available if anything below him ever let go without warning. But could the steel itself actually survive this kind of punishing stress, day after day, year after year, for decades on end without giving out? That was the real question, facing Wellman's engineers, and they answered it with chains and gearing rated heavier than almost anything else. Standing on the Great Lakes waterfront, drive chains thick as a man's forearm, gearing left fully exposed along the towers, because in 1912 nobody buried the moving parts inside sealed housing. You let men see the gears turning. You let them hear the chains running. And then you let them work directly around all of it, every single shift. Here's exactly what that engineering bought the city of Cleveland in hard numbers. Hand shoveling had cost somewhere around 18 or 19 cents a ton, all in. A working Hulett dropped that figure down to roughly 5 or 6 cents a ton. That's not a modest improvement on the old method. That's an entirely different economy built on top of the same lake, the same ore, and the same ships. And the change didn't stop at unloading speed, it physically reshaped the ships themselves. Freighters, built after 1904, had their cargo holds completely redesigned, stripped of the old support beams and stanchions that used to hold the structure together. Specifically so, a Huletts bucket could reach 98% of the cargo without a single man ever having to touch it by hand. Boats doubled in length within a decade. Their capacity quadrupled. The machine didn't simply serve the existing industry. It quietly rebuilt the entire industry around its own specifications. In case the scale still hasn't fully landed, stand a battery of these machines side by side, and they rose taller than the bronze guardians of traffic that still watch over Cleveland's bridges to this day. Their footprint on the dock was wider than a space shuttle's. Fully loaded and running, they weighed more than the freighters they were unloading. Was there ever a real rival? Did some competing firm somewhere try to beat George Hulett at his own game and build something faster, or cheaper, or safer? Here's the honest answer the research actually supports. There's no documented head-to-head rivalry, no competing unloader design that genuinely tried and lost in the historical record available to us. So we're not going to invent one just to give you a villain in this chapter. What we do know, with certainty, is that by 1913, 54 Huletts were already running along the Great Lakes, with several more already on order for U.S. Steel's brand new Gary Works going up on the dunes of Lake Michigan. The machine never needed a rival to beat. It had already won the only competition that mattered before most competitors even understood there was a race happening. The engineering problem, by every measure that counts, had been solved. The economics were a runaway, unqualified success across the entire region. But solving how the machine worked was never going to be the hard part of this story. The hard part, the part no engineer ever put down on a blueprint, because it wasn't really an engineering problem at all, was what it would feel like to stand next to this thing, shift after shift, for the next 80 years of its working life. Ore hogs. They called the men who worked these machines ore hogs, and the name was never meant to sound gentle. Because, here's the part, the original engineering drawings never accounted for. Even a machine this advanced still couldn't finish the job entirely on its own. As a ship's hold gradually emptied out, the bucket would eventually reach a point where it simply could not scrape up what remained. The geometry didn't cooperate anymore. The ore was scattered too thin. Pushed too far into corners, the bucket's reach couldn't follow. And when that moment came, there was exactly one available solution. A man climbed down into the hold, on foot, carrying a shovel, and he piled the remaining loose ore into reach of a bucket that was, at that exact moment, still swinging through the very same enclosed space he was standing in. Sit with that for a second, because it matters. The entire stated purpose of this machine was to pull men out of the most dangerous part of the job, and the work itself still required them to climb straight back into it, by hand, every single time a hold ran low, which, on a working ore dock, was constantly. The operator riding up top had it dangerous, in a completely different way. Picture 8 hours, 10 hours, sometimes more, locked into that narrow cage hanging above the bucket through a full Cleveland winter, with wind cutting sideways off Lake Erie and ice forming overnight on every exposed rail, chain, and gear on the machine's exterior. The cab itself swayed gently whenever the beam moved. The entire structure groaned audibly under its own shifting weight. And below him, constantly, without pause, the bucket kept closing, lifting, swinging, dumping, and closing again, in a rhythm that did not slow down for fatigue, for numb fingers, or for a man who hadn't slept well the night before. And the rest of the machine never sat still around either of them for a single moment. The receiving hopper running between the main girders slid forward to catch the bucket's freshly dumped load, then slid back to empty itself into a waiting rail car, or swung outward onto a separate cantilever arm to drop the same ore onto a growing stockpile instead. Heavy, moving steel in every direction, all day long, running on a schedule set entirely by the ship's emptying hold, never by the comfort or convenience of the men working underneath it. And this wasn't seasonal work that let a man rest through the worst months. The Great Lakes shipping season ran from spring thaw to the first hard freeze, which on Lake Erie meant a brutal stretch of late fall and early winter when ore traffic actually peaked, because every mill wanted its stockpiles topped off before the lake closed for the year. That meant the worst weather and the heaviest workload landed on the same weeks every single year, for 8 straight decades. A man working the hold in November wasn't just dealing with shifting ore and a swinging bucket. He was doing it with frozen gloves, ore dust crusted into ice on every surface, and a wind coming off open water that could drop the felt temperature well below anything the calendar said it should be. So, how long could a man actually last doing this kind of work, year after year? How many near misses happened on some completely ordinary Tuesday afternoon that nobody ever bothered writing down, simply because nothing technically went wrong that particular time? Here's where we have to be straight with you. Because we promised at the start we would be. We genuinely don't know. There is no surviving ledger of Hulett-specific injuries or deaths for the Cleveland machines that we could find. No running tally anywhere. No names carved into any monument that say this. Many ore hogs paid this price for that many tons of ore moved. That silence is not nothing. And it's certainly not good news dressed up to look quiet. We are not going to invent a body count just to make this story feel more dramatic than the honest record allows. But we do know, with real documentation behind it, what work like this generally cost men in this exact industry, during this exact era. The broader Great Lakes steel and ore handling trade left behind a very different kind of paper trail written in lawsuits, in occupational health records, in decades of well-documented asbestos exposure at mills like Great Lakes Steel out on Zug Island, where men working in conditions not far removed from a Hulett dock breathed in particles that would go on to kill some of them years, sometimes decades, after they'd already clocked their very last shift. The Huletts themselves left no individual record behind. The industry surrounding them left plenty. Set those two facts side by side, and the silence specifically around the Huletts starts to sound less like good news and a lot more like a story that simply never got written down by anybody who was paying attention. And remember that 6,000-pound counterweight still doing its quiet, constant work in every one of these stories, letting the whole arm drop on command whether a man happens to be standing underneath it or not. We're getting to exactly why that detail matters more than it might seem right now. Hold on a little longer. For 80 straight years, that was simply the deal on Whiskey Island. The machine did the impossible part. The men did the part the machine still couldn't manage alone. And somehow, through ice storms, through war years, through every single shift change across 8 uninterrupted decades, the Huletts kept running without a documented catastrophe ever forcing them to stop. They beat the lake. They beat the weather. They beat the slow, grinding mechanical wear that kills most machines half this size in half this time. What finally came for them, in the end, wasn't an accident at all. The day they cut them down. By the early 1990s, the Great Lakes shipping industry had quietly built something that made the entire Hulett system obsolete almost overnight: the self-unloading freighter. But before that ending, the climbing risk this story has followed since Chapter 1 had to land somewhere. For 80 years, men rode that cage above the bucket and climbed into holds beneath it, and the record stays quiet on exactly how many close calls never made it past a shift report, if one was ever filed at all. That silence is the closest thing to a single dramatic accident this story has, not because nothing ever almost happened, but because nobody wrote it down where it could survive to be found. The catastrophe this story builds toward isn't a single afternoon. It's 80 years under 800 tons of unbalanced steel, and then watching the machine itself get killed by something far more mundane than anything the lake or the bucket ever threw at them. A ship that carried its own conveyor system built right into the hull, fully capable of dumping its own cargo without a single shoreside machine ever touching it, was the thing that finally did it. No Hulett required anywhere in the process. No ore hogs required either. By 1992, 61 of the 66 American carriers working the Great Lakes were already self-unloaders. The technology that had built Cleveland's entire steel empire from scratch had been quietly out-evolved by the very ships it used to serve. At the end of the 1,992 shipping season, the last 4 Huletts standing on Whiskey Island went silent for the final time. 80 years of continuous service ended not with an explosion, not with a headline disaster, but with one final ship simply pulling away from the dock, and nobody ever needing the machines again after that. And here is where the real fight of this entire story actually begins, not a fight against ice or weight or gravity, but a fight against a wrecking ball, fought in courtrooms instead of on the dock. Conrail, which had inherited the docks by then, and the Cleveland-Cuyahoga County Port Authority both wanted the Huletts gone for good. Dead weight, sitting on increasingly valuable waterfront real estate. Preservationists, engineers, local historians, a small and genuinely stubborn group who eventually started calling themselves the Hulettiers, said absolutely not without a fight. In June of 1993, Cleveland's City Council granted the machines formal landmark status. In August of 1998, the American Society of Mechanical Engineers went considerably further, naming them an official historic mechanical engineering landmark in a ceremony attended by nearly 500 people aboard a Lake Erie cruise boat. A year before that, the machines had already been placed on the National Register of Historic Places. 3 separate formal recognitions of genuine historical significance stacked one on top of the other. And in December of 1998, after all 3 of those protections were already in place, the Port Authority and a private terminal operator filed for an official permit to demolish the machines anyway. Could a piece of paper actually stop 800 tons of unwanted industrial steel from going straight to a scrapyard? That exact question played out in courtrooms and hearing rooms for most of the following year. By late 1999, both sides finally settled on a compromise. All 4 remaining machines would come down off the dock, but 2 would be sold for scrap immediately, while the other 2 would be carefully disassembled and stored in pieces on Whiskey Island, kept intact and waiting for someone, somewhere, to find the money and the location needed to reassemble them as a permanent public display. That storage arrangement was supposed to last 5 years at the most. It lasted 25. What does 25 years of waiting actually look like for a dismantled 800-ton machine? It looks like steel sitting exposed to lake weather. It was never designed to weather while sitting still. It looks like vegetation creeping up through stacked beams that used to move freight at 1,000 tons an hour. Preservationists later said the port had let the storage site grow over, the very pieces meant to anchor a future museum display slowly disappearing under weeds and rust, while everyone waited for a check that never arrived. The machine that had once beaten ice, wind, and 80 years of non-stop industrial use was, in storage, slowly losing a much slower fight against simple neglect. The 2 surviving Huletts sat disassembled on Whiskey Island for a full quarter century, tangled the entire time in a separate legal fight against the U.S. Army Corps of Engineers over a dredging permit that had quietly included authorization for their disassembly in the first place. A 2018 agreement finally gave preservationists one more fresh window, 3 years this time, to raise the money needed to put the machines back together somewhere, anywhere, on a permanent basis. The money never came. Not close to enough of it, anyway. There was, for a while, a genuine flicker of real hope. A demolition company called Maple Leaf, based on the site of a former Timken steel plant in Canton, agreed to take custody of one of the 2 remaining Huletts and rebuild it whole again. On their own private property, an actual second life for the machine, not simply a static, rusting piece sitting in somebody's parking lot. For one stretch of months, it genuinely looked like at least one of these giants might survive completely intact. It fell apart over something that should sound almost insultingly small compared to everything that came before it. Maple Leaf could not secure the bonding and insurance the contract legally required of them. Not a wrecking ball, not a sudden lack of will or commitment on anyone's part, a routine paperwork requirement that an entire, hard-won rescue plan simply couldn't clear in time. So, in March of 2024, the Port of Cleveland signed a brand new contract, this time with a scrap removal company, not a preservation-minded one. And in June of 2024, the last two Hulett ore unloaders, standing anywhere in the very city they had helped build into a steel powerhouse, were cut apart, piece by piece, and sold off for their raw metal content. No accident took these machines down. In the end, no storm, no sudden structural failure, no single catastrophic afternoon that made the local news. They had already survived all of that, every bit of it, for 80 uninterrupted years. What finally killed them was something far simpler and, in its own way, far harder to watch unfold. Time, money, and a legal clock that quietly ran all the way out. For the small group of preservationists who'd spent 3 decades on this fight, the announcement landed less like news and more like a death they'd been bracing for since the late 1990s and had simply never finished grieving. One of them called it extremely disappointing, a quiet, almost clinical word for watching something you'd fought a quarter-century to save finally go to the torch anyway. The dead were buried, except there were no dead in any record anyone ever managed to keep. Just a machine, finally, quietly, gone for good. And almost nothing of it left behind to show it had ever existed at all. What's left on Whiskey Island? Almost nothing, but, in the end, not quite nothing. As part of the final agreement before the torches went to work, the Port of Cleveland deliberately set aside 2 specific pieces. A 60-foot bucket arm, along with its bucket, preserved for a future public display planned at Wendy Park, just a short distance down the shoreline from where the machines themselves once stood for 80 years. A separate shunt engine, part of the original ore unloading system, was carefully saved and shipped off to the American Industrial Mining Museum in Brownsville, Pennsylvania, where it sits today, hundreds of miles from the lake. It spent its working life serving. $250,000 went to Canalway Partners. Another $250,000 went to the State Historic Preservation Office. Money, set aside in place of metal. A consolation, of sorts, for people who had spent the better part of 3 decades trying to save something that, when it finally came down to it, nobody could find a way to lift. And that brings us, finally, back to the 6,000-pound counterweight, the detail we told you to remember all the way back at the beginning of this story. That counterweight was the entire genius behind the original design. It let gravity itself handle the deadliest, heaviest part of the machine's daily work, so the motor never had to fight physics the whole way down. It's the reason the Hulett could drop its arm into a ship's hold faster and more efficiently than any rival system ever managed, the reason it could move 17 tons of raw ore in a single bite, the reason it built an entire regional industry around itself in barely 15 years. But that exact same physics, an enormous, deliberately unbalanced mass of dead steel, built to want to fall, is precisely why nobody could simply pick this machine up and move it somewhere safer once it stopped running for good. An object engineered from the very beginning to be unbalanced doesn't suddenly become easy to relocate just because people want very badly to save it. 800 tons of purpose-built, asymmetric steel is exactly as immovable in death as it was unstoppable in life. The same design choice that let the Hulett conquer Lake Erie's docks for 80 straight years is the same design choice that made rescuing it, decades later, nearly impossible without millions of dollars that nobody ever actually managed to raise. So look at what this single machine actually built. While it still stood, Cleveland Cliffs, Sherwin-Williams, an entire steel mill geography strung along Lake Erie's southern shore, clustered exactly where it was because that's precisely where the ore came off the boats the fastest. Industry figures who've studied the city's growth put it plainly. Those companies, in the form Clevelanders know them today, really wouldn't exist without what the Huletts allowed onto those docks. The mills didn't choose their location by accident. They built where the ore arrived fastest and cheapest, and for the better part of a century, that meant building near a Hulett, the SS William G. Mather, now a floating museum sitting a few hundred yards from where the last Huletts came down, was a freighter, literally designed from the keel up around being unloaded by one of these machines. You can walk its deck today and stand on a ship built specifically to feed a beast that no longer exists anywhere in the world. Across their full service life, the Huletts of Whiskey Island alone are estimated to have moved something like 100 million tons of ore, coal, and limestone through Cleveland's docks. System-wide, across every single Great Lakes port that ever installed one, the total runs into the billions of tons. Every ton of that fed a furnace somewhere. Every furnace fed a mill. Every mill, in turn, fed a city that called itself, without much exaggeration at all, the place that quite literally built America's steel. The men called it the ore hog, and they feared what it could do to a body caught in the wrong place at the wrong moment. And that fear, as far as anyone can tell, was entirely earned, even with no clean ledger anywhere to prove exactly how earned it really was. But that same machine is also the reason there was ever a mill to work in, a paycheck to carry home, a Cleveland skyline built on the back of ore it tore out of frozen lake water across 80 unbroken winters. They don't make machines like that anymore. In the end, they couldn't even save the ones they already had. What's left is one arm, one bucket, and a single shunt engine scattered between a Cleveland park that hasn't been built yet and a museum 2 states away, the last fragments of 80 years that fed an empire nobody remembers building.